Hello, welcome to the How to Go Solar and Storage webinar. My name is Abby Jager. I'm a program manager with Solar Oregon. Today we're going to be going through everything you need to know in order to get solar for your home or business. First off on the agenda for today, like I said, we're going to be going through what you need to know in order to get solar for your home or business. So we're going to start off by talking about how solar works and how you can know if your home is right for solar. We'll then dive into the exciting topic of home energy storage and then talk about some of the available incentives and price tags for the different things we will be discussing. We will then talk about what you need in order to get started. I'm going to go through a few more housekeeping things, and while I do that, I'm also going to start some polls. These are completely optional and are just a way for us to collect some data about who's attending our webinars that we can use for grant and under other funding opportunities. Now, first off, a little bit about the organization I work for, and that is putting on this webinar today, Solar Oregon. Solar Oregon is a 501c3 nonprofit that focuses on education, outreach, community, and advocacy around solar power and other renewable energy alternatives. We do this through a variety of educational programs, including our Hallmark program, our How to Go Solar Plus Storage webinar, solar tours of local homes and businesses that have solar power, solarized campaigns, and also other peer-to-peer and community education events. You can support our work by becoming a member or going on our website. You can also follow us on social media and Eventbrite at Solar Oregon in order to find out about all the great events we have coming up. And thank you so much for filling out this first poll. I'm going to end that one and start the next one. Upcoming events we have. Next week, we'll be doing a special event in honor of Earth Day, talking about solar panel recycling. This will be covering what you need to know in order to recycle your solar panels and also to discuss a little bit about where solar recycling is going, looking towards the future. And thank you for answering that poll. And there's one last poll I'm going to launch. This workshop is also made possible by support from the Energy Trust of Oregon. Energy Trust of Oregon is an independent nonprofit that provides access to affordable energy. They serve the 2.4 million customers of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. Thank you so much, Energy Trust of Oregon, for your support. Throughout this presentation, if you have any questions, please use the Q&A function within the at the bottom of your screen. At the end of the presentation, I'll be going through all the questions put in there in order to help answer them. The chat will only be open to myself as a way to send resources and helpful links that I will be discussing. Now I'm going to end that last poll. Thank you so much for those of you who answered. We really appreciate it, as it really does make a difference in us being able to know more about who we are serving and create better educational opportunities for everyone. So now I'm going to dive right into how solar works. So first up, here's a diagram of a standard solar system. So on the top left, we have a photovoltaic or PV panel. This is what would be mounted on the ground or on the roof of your home that is then hit by the sun and generates a volt of electricity. From that PV panel, that volt of electricity then flows down to a special device called an inverter or microinverter that I will be discussing in more detail on the next slide. That converts the electricity from DC electricity, direct current, to usable AC or alternate current electricity to be used by your home. From there, it then flows to your home electrical panel, where it can power your dishwasher, charge your electric vehicle, turn on your lights, and charge your phone, and do everything that we use power and electricity for. If at any point in time your photovoltaic or PV panels are generating more power than your home is needing at that particular moment in time, the excess power you are generating flows out through your utility meter. When you get solar, a new utility meter is installed. That is a bidirectional utility meter and allows electricity to flow in both directions. After So if at any point in time, like I said, your solar panels are generating more power than you're needing, that excess power flows through your utility meter where it is tracked and then flows out to the utility grid to be used by your neighbors. And the reverse is also true, if at any point in time you are not generating as much power as your home needs, such as at night when there's not enough sun, then that utility meter will pull power from the grid in order to power your home. This is called a grid-tied solar system, as you are still connected to the grid as opposed to something like where you are out in a cabin in the middle of nowhere or an off-grid system. So now, like I mentioned, there's a special new device you get when you install solar panels called an inverter. An inverter is what converts the electricity generated by the panel to usable electricity for your home. There are two main types of inverters: string inverters, which is pictured on the left, and microinverters. Both are great options that are installed frequently throughout Oregon. The main differences is that a string inverter takes in all the electricity from all your solar panels all at once and converts it all at once. So for a system of 10 panels, you would have only one string inverter that is working to convert that electricity. While in contrast, microinverters, which are these black boxes, are mounted on the underside of your solar panels, and you would have up to one for every panel. So they only take in electricity of 1 to 2 solar panels at a time. So for a 10 panel system, you could have up to 10 microinverters, depending on the size of the panels and the amount of electricity you'll be generating. As I said, both are installed frequently throughout Oregon. It really just depends on the needs of your specific system, and your solar contractor will be able to tell you which one they would recommend for your home. Now, where do these solar panels go? So the most common here I'm in Portland, Oregon. So in Portland is roof-mounted solar. This is when you mount the solar on the roof. This is most common in high-density residential areas like Portland, where ground space is at a premium. However, if you're farther out in the country or have a little bit of space to spare, ground-mounted panels, like pictured on the right, can be a really great option. These do sometimes come with some extra costs, as they can be farther from your electric panel and require some extra wiring, but if you have the space, it can be a really great option for you. Another option is solar roof tiles. This is a solar product that is also a roofing product, so both generates electricity with solar panels and also is your roof. So rather than solar panels being mounted on top of your roof, it's an all-in-one product. There are several brands available, however, it is newer tech and therefore is much more expensive. Price declines have been predicted over the past number of years. However, none have really come to fruition in a large way yet. And so this product still remains to be a newer technology that isn't installed quite as often. If you are interested in getting solar roof tiles, I highly recommend working with a contractor who has familiarity with them and has installed them before. So now that I've talked about some of the basics of solar, let's talk about how solar can actually help save you money. Here in Oregon, we utilize a system called net metering that allows you to build up credits during the sunny summer months and then use those credits up during the winter. So to explain how this works, I'm going to walk through 2 examples using these graphs and then also show what it would look like on your electricity bill. So it's almost summer. I'm pretending it's already spring, so therefore it's almost summer. It's already pretty sunny, but we can think a little bit further ahead to when it's going to be super sunny, 75-degree blue, clear skies, no rain at all. And your solar panels are producing so much electricity. That's this very large orange bar over on the left. And your consumption of what you actually need to power your home is only about half that. So all that excess electricity you are producing is flow out to that grid to be used by your friends and neighbors and will be tracked, earning you net metering credits every single month because you are generating electricity for the grid. Now let's think back to some of the colder days. I know there's thunderstorm warnings last week, so that's a perfect example. It was cold and rainy and gray and not sunny at all, but your solar panels are still producing a little bit of sun. Even when it's cloudy, there's some sun rays getting through and it produces some amount of power. However, it doesn't quite meet that amount of consumption you need in order to power your home. Therefore, you're going to need to draw more power from the grid. Luckily, you built up all those net metering credits during the sunny summer months and then can use that to offset your bill and help pay for the power you are then needing to draw from the grid during the cloudier winter months. Net metering credits roll over from month to month, so that's what allows you to build up credits all summer long to use up all winter. However, they do not roll over from year to year. The net metering year begins and ends on March 31st, and therefore any credits you have at the end of the day on March 31st, you forfeit, and they are donated to low-income subscribers. And unfortunately, PGE or Pac Power will not cut you a check for those excess credits. This is why sizing your system to meet and not exceed your expected power use is very, very important. So what does this actually look like when it comes to your bill? So here on this bill, we can see that the meter reading at the beginning of the month was meter reading at the beginning of the month was 237, and the excess generation meter at the end of the month was 564, meaning this customer generated an extra 327 kilowatt hours of energy. That makes their billable kilowatt hours for this month 0, and that negative 327 gets added to their year-to-date banked excess generation, meaning they have 3,072 excess kilowatt hours to use up once it is those cloudier winter months. Now, despite the fact that they have a billable kilowatt hours of 0, their final bill at the end of the month is not 0. They still have to pay, in this case, $12.63. Nowadays, it's usually for most customers between $10 and $20, depending on where you are, in taxes and fees just to be interconnected to the grid in the first place. So while it's unfortunate your bill will not be $0.00, $12 is much less than the average utility bill here in Oregon, which is around $70 to $80, and it will not go up at the same speed with rate hikes due to the fact that you will only be paying for that basic connection to the grid charge and any taxes. So with that, like I said, system sizing. You want your system to meet and not exceed the amount of electricity you consume and need on a regular basis. Solar panel size is measured in kilowatts, and the average size here in Oregon is about 8 kilowatts. It's very important to size your system correctly, as you don't want to be paying for any excess generation in the form of having more solar panels that you're then paying for that you don't actually need. Other factors that might contribute to the size of your system is the available space, your budget, and any aesthetic concerns. Your solar contractor will ask to see some of your previous electricity bills and also talk to you about any lifestyle changes you might be planning, such as having someone move in or out of your home, or electrifying any appliances, or updating anything to be more efficient. All of these will impact the amount of electricity you need and are great things to talk with your solar contractor so that they can be prepared and size your system correctly. So now, how can you know if your home is right for solar? So first off, no matter where you are in Oregon, in general, Oregon has enough solar access. We can see here the sun at the summer solstice when it's at its highest point in the sky, and the winter solstice when it's at its lowest. And through this diagram, we can see that the sun is always in the southern part of the sky and never crosses that line over to the north. This means that solar panels can be installed on ideally a south-facing roof plane, but they are frequently installed on the south, east, and west, and really just avoid north, northeast, and northwest planes. One thing, though, that we cannot predict from a simple sun diagram, though, is the amount of shade your home has. If your home is very well shaded, like these gorgeous homes here, then you may not be a great candidate for solar, as your roof is too blocked from the shade you're receiving. However, don't despair if your home is shaded. You don't want to cut down those beautiful trees. They do great things for our environment and help keep your home cool, lowering your energy costs overall as well. Instead, I would highly recommend looking into community solar. And at the end of this presentation, I'll put some links in the chat with that information. Another thing that can impact the size of your solar system is your roof complexity. A complex roof, like pictured on the left, while it may have lots of south-facing roof planes, they're all pretty small and very divided up with lots of things that would prevent it from being one continuous solar array. It is possible to put solar on these types of roofs, but it can just add cost and complexity in comparison to a roof like the one on the right that is very simple and has one continuous roof plane. Now, not only the size and shape of your roof matters, but also the condition of it. We recommend that you have 10 plus years of roof life left on your roof before getting solar. This is because solar must be taken off when you are re-roofing your home. And if you have an older roof, we recommend waiting until after you re-roof to just save on some of those costs. Now, not only what's on top of your roof matters, but also what's under it. If you're having roof-mounted solar, then your roof needs to be able to support the added weight that comes with it. No matter what, trusses like pictured on the left will be able to meet even the strictest definitions of what is needed in order to support solar. However, if you just have rafters, like what is pictured on the right, this is very common in some of the older homes in the Portland area, you may need to get some extra engineering work done in order to either prove that the rafters are sufficient to support the weight of the solar panels, or even add in some extra trusses and support in order to make it sufficient for that added weight. Now, the next thing that also comes up are electrical panel upgrades. If you have an older home, you may need to upgrade your electrical panel in order to go solar. When doing this, you want to consider your electricity consumption and your surge capacity in order to ensure that your home is being wired correctly and that your electric panel can support everything you are wanting to do. You can also plan for consumption changes, like adding an electric appliance when you're working on updating your electric panel. Like many of the other things I'm talking about, this is a very common thing we see in electric panel upgrades. It will just add some added extra cost to your solar system. So now that I've gone through some of the basics of solar, let's talk about home energy storage. So solar plus storage is more efficient because it provides you the ability to have energy resilience, which is the ability to use power when the grid is out. Your solar charges your storage, and then you can retain power and even recharge your storage system when the grid is down. So here's just a quick example of what that looks like. So we have solar on the roof, pictured on the right, and a battery in the garage, pictured on the left. So now, why would you want energy resilience? You can want energy resilience for a lot of different reasons. You might experience short common outages caused by storms or squirrels. Here in Oregon, we also have the unique risk of public safety power shutoffs, and this is when the electric company shuts down the grid in order to lower the fire danger in a particular area. This first of these happened in 2020, and they have been used frequently as a fire mitigation effort since then. We also have the unique risk of the Cascadia earthquake. This is the large earthquake that is reported, that is predicted to hit the PNW at some point in the next number of years, and is predicted to cause the Willamette Valley to lose power for up to 3 weeks and over a month over on the coast. So these are also the reasons you might want to have energy resilience. So when it comes to picking a battery, there are many brands and chemistries available. However, installers may specialize in one specific battery, and you are unable to mix and match. So if you know you really want a Tesla Powerwall, but you already have an ion battery, you would only be able to get a Tesla Powerwall if you fully disconnected and got rid of that ion battery that you'd installed previously. So because installers specialize, if there is one specific battery you want, I highly recommend talking to your installer and making sure it is one they are comfortable installing and have worked with before. If you're planning to power any motors, it's also important to check the surge capacity on your battery. Apologies. Excuse me. When it comes to backing up your home, there are two options. There's a partial home backup and a whole home backup. It can be prohibitively expensive to back up your entire home for a significant length of time. This will require multiple batteries, and like I said, can just be prohibitively expensive. Due to this, what many people choose to do is a partial home backup, where they select certain circuits and areas of their home to retain power in the event of an outage. So when it comes to this, it's a question of what needs power and for how long. It's a balancing act, as obviously the more things you have drawing power from the battery, the shorter length of time it will last. However, you also want to try and make your home be as comfortable and useful for you during a long-term power outage as possible. What most people choose to back up is a fridge or other similar appliances, some lights in common areas, and maybe an outlet or two. Then the way we do a partial home backup is through an essential loads panel. This is when you create a separate utility panel that's usually just put right next to your original electric panel, and certain circuits are moved physically from your original electric panel to this secondary one. This does add complexity and cost. However, like I said, it can be a great option if you want your home to be more energy resilient. The second option, if you don't want to have a secondary electric panel, is a smart electric panel. This provides you flexibility and customization in that you can easily move circuits from a nice to have category to a must have category to a never retains power from just an app on your phone or from the website. However, this is a newer technology and as such does cost more. However, it can be a really great option if you have the funds for it. And I've seen people use these in really creative ways, such as turning off the power to a video game system if their child is in trouble and isn't supposed to be playing on it. So there's a lot more customization that is available with this that some people really enjoy. So now there's a question of when do you install storage? There are two options for storage. There's AC coupled storage. So this would be storage that is placed before or after your inverter, so after your electricity from your solar panels has been converted to AC versus DC coupled, which would be placed before. If you install solar and storage, you can save some money and also some time. And storage being added to an existing solar system does come with an extra cost. The other thing to consider is that batteries require space. Ideally, batteries can be placed near an electric panel. However, they can be placed anywhere as long as it is not within a crawl space or cupboard, including outside, and any batteries being installed must meet the National Electric Code. Now that I've gone through all these great pieces of technology, let's discuss the available incentives that can help you pay for them. So first off is the Solar Investment Tax Credit, or ITC. This is the 30% of the total cost of your system as a dollar-for-dollar tax credit. I'm going to go through some more details of the ITC, but really quick, this is not official tax advice. Right now, I kind of wish I was an accountant, as I'm sure my tax return would look a lot better than it is when I submitted it this weekend. But I am not, and this is not official tax advice. If you would like any official tax advice, I highly recommend reaching out to a tax professional and only trusting tax professionals. With that being said, here's some information about the investment tax credit. So this is a 30% dollar-for-dollar incentive that can be applied to both solar and storage. It can be claimed over several years if you do not have enough tax liability to claim it all in 1 year. This has potential to really help you in terms of offsetting your taxes and getting some money back for that solar system you installed. However, there are many common scams as well. The most common one I hear about is people claiming that re-roofing costs can be claimed on this tax form. However, that is not true, and the IRS has come out saying specifically that the investment tax credit does not cover re-roofing costs, even if you're re-roofing in order to get solar. So now, in addition to that federal tax incentive, there are also incentives offered by the Energy Trust of Oregon. Energy Trust of Oregon offers two standard incentives, one for solar, which is $950 for PGE customers, and $1,100 for Pacific Power customers. And then they also offer an incentive for storage, which is $450 per kilowatt hour, up to $5,400 for PGE customers, and $475 per kilowatt hour, up to $5,700 for Pacific Power customers. These incentives are really easy to claim because you as a customer only have to do one thing, which is work with an Energy Trust of Oregon Trade Ally certified contractor. These are contractors that have already been vetted by Energy Trust of Oregon and therefore are approved to offer Energy Trust of Oregon incentives. Your Trade Ally contractor will apply for these incentives on your behalf, and assuming they follow all Energy Trust of Oregon design and installation requirements, which as a Trade Ally they should be doing, you will receive just the discount on your final bill. In addition to those two standards incentives, Energy Trust of Oregon also offers an income qualified program called Solar Within Reach. These incentives are structured very similarly, where there's an incentive for both solar and storage that varies a little bit in terms of dollar amount based on your utility. And in order to qualify for this program, you have to work with an Energy Trust of Oregon trade ally contractor. The income threshold cutoff for this program is very generous. For a household of 4, the income threshold cutoff is $128,000, $564. And you can find more information at energytrustoforegon.org/solarwithinreach. Now I'm going to go through some different budgets on how much solar can cost in just a minute. However, before I do that, I'm just going to review really quickly why the costs of solar systems can vary so much. And while I'm going through the budgets, these are just a sample budget for an imaginary system, and your exact quote might look a little bit different. So the reasons costs can vary when it comes to solar is the size of the system, whether or not you need to re-roof, if you require any structural analysis or upgrade, what incentives you can access, and then also possibly some interconnection fees. When it comes to storage, costs can vary based on whether or not you're installing it at the same time as solar versus later, the number of batteries you are getting, if there is an essential loads panel, how far you are installing it from the electric panel, and how many incentives you can access. So here's a sample budget for an 8 kilowatt solar system. So the cost before any incentives for an 8 kilowatt system in Oregon is about $32,000. From there, based on your utility, you can then claim the Energy Trust of Oregon incentives and possibly those higher Solar Within Reach incentives if you are income qualified. After that, the out-of-pocket cost to the customer is about $31,000, or if you are income qualified, is around $26,000. From there, you can then claim the 30% solar investment tax credit, which lowers that price further, making the final cost to you, the customer, before energy savings about $21,600, or about $18,000 if you are income qualified. Now, if you're installing both a solar and storage system at the same time, so an 8 kilowatt solar system plus a 13.5 kilowatt hour storage system, the cost to the customer is about $52,000. You then can claim the Energy Trust incentive, and that lowers the price further. The state rebate is currently unfunded, which is why that is zeroed out, as you would be unable to access that money. Hopefully, it might be getting refunded this legislative session. However, we are unsure on what that will look like for sure, as we're waiting to see what comes out of Salem. That makes the out-of-pocket cost to the customer $45,200, or about $35,000 to $36,000 if you're income qualified. You then get to claim that 30% federal tax credit, and the final cost to the customer for energy savings for this system is about $31,600, or about $25,000 if you're income qualified. Now, if you're adding that storage system after you've already installed solar, so it's that same 8 kilowatt solar, but you have that added 13.5 kilowatt hour storage added after. So it's $32,000 for the cost of solar, then an extra $23,000 for adding that battery system after. You still get to claim the full amount of all Energy Trust of Oregon incentives, and you get to claim the full amount of that 30% federal tax credit, but that higher dollar amount makes the final cost to the customer before energy savings closer to $34,000, or about $27,000 if you are income qualified. Now, these are all some really big numbers, so I want to reassure you that financing is very common. There are some loans that are tailored specifically to solar that will allow you to refinance your loan after claiming that 30% federal tax credit and using that to help pay down. Your installer may have a financing partner, but we also recommend that you reach out to your bank and local credit union and explore all your possible options. And as always, consult a financial professional for any official advice, as this is not that. Now, with all this information, how do you get started? As I mentioned, in order to fully access those incentives, I'd highly recommend working with an Energy Trust of Oregon trade ally contractor. These are contractors that have been rigorously qualified and approved to offer Energy Trust of Oregon incentives and are familiar with all Energy Trust design and installation requirements. You can request a quote from a trade ally contractor by going on the Energy Trust of Oregon Request Custom Analysis and Solar Bid tool. This will connect you with up to 3 trade allies that work in the area of your home in order to receive quotes. I will be putting a link to that to the chat in just a moment. Once you receive quotes and sign the contract, it is then time for installation. Your contractor will complete all paperwork except for the tax credit. In general, permitting can take between 2 and 12 months, depending on where you are in the state. However, once all your permits have been issued, installation is very quick, usually only taking about 1 to 4 days, and your contractor will manage all inspections and interconnections after the installation. So all you have to do is flip on your light and know it is coming from clean, renewable energy. So now with all that being said, I'm going to stop sharing my screen and grab those links for everyone really quick and then go through the Q&A. Okay, I know there's already a lot of questions in the chat. Okay, so the first question I have is, was March 31st chosen so that credits were the least? Actually, the opposite. So March 31st is what they decided was the optimal date in order to optimize the number of credits you have, amount of time you have to build up all those sunny summer month credits. So March 21st is the spring equinox, and when we typically see a switch, and theoretically would see a switch from the gray cloudy weather to the warm sunny weather. And so by switching it over at the end of March, we're able to optimize and have you start building up those net metering credits very quickly to then use them up all winter long and then have enough time to use up all those credits. So it's not something they were doing to try and trick you. It's actually something they're doing to try and optimize. Correct. And so then we have another question about when it comes to system sizing, it's important to remember adding in electric vehicles electrification, and that's very correct. Those are all things that you'd want to discuss with your solar contractor. If you're planning to get an electric vehicle, that would definitely impact the size of a system you need. We then got a question about whether or not the federal tax incentives can be applied to solar costs regardless of Energy Trust incentives. So as I said, I'm not a tax professional, but from what I understand, the amount of federal tax credit you can claim would be the out-of-pocket cost you paid. So that cost of your system minus the Energy Trust of Oregon incentives. However, I would consult a tax professional to get that question answered more clearly. I'm also going to launch one last poll that's just about how I did and if I answered questions correctly, but please keep putting questions in the chat. I'm happy to answer them all, and I'm here to help answer your questions. Thank you all for answering that final poll. I'm happy to stay on and answer questions for as long as people need to. I've put my contact email in the chat. However, so you can also reach out to us there if you have any other questions. But thank you so much for attending today. And I hope to see you at another event soon.